Now students, let us see how sound get produced. As you know that we are able to hear anything because of our ears, right? Yeah, but what does the ears have? They initially are having the core part that produce the sensation, and that sensation get transmit to the brain, and our brain is able to get the value what is we are hearing. That is all process. But how does it produced? How we are able to produce it? Okay, so there is a reason. Like the thing, if some bell is ringing, that bell is not a human or any living thing, but still it is able to produce sound. Now I am a living being, but still I am able to produce. So sound doesn't relevant to the living or the non-living things. Then how? What is the main reason behind the production of the sound? So here it is produced by the vibrations of different objects. Okay, vibration is like the vibrate, like moving from, if particle is here, it is moving in this direction, like to and fro motion. Okay, this is vibration. Fine, like your phone get vibrates. So vibration means that some particular waves are transmitted out of the device, that it get inside the body and that we can able to feel. Okay, so basically vibration का क्या मतलब है? That any particle which is at its rest position right now but starts moving like this, like this, like this. So this is basically a vibration, and this is produced when some energy is given to that particle. Okay, now energy. Who is giving the energy? Any object which is get strike with each other, like you are clapping your hands, still you are making a strike method. Okay, so you are using this method and disturbing the environment particles around you. So what we are actually saying? Disturbing the particles. Like initially the particles are at rest position. Let me make a particle for you. Like these are the particles. Fine. So they are at the rest position. No vibrations is there. Yani ki no disturbance is there. They are just keeping well and they are staying here. But when some external thing is coming and pushing it, okay, so this will get vibrate first. And when this will get vibrate, this will make this also get vibrate. And when this will get vibrate, this will get this also vibrate. Likewise, the chain goes. Okay, so this is how the disturbance in the atoms and molecules is known as the vibration. And because of vibration, we can say that the sound get produced. Okay, so what is vibration? As I have told you, if the definition parts come, so this is the definition part. Rapid to and fro motion. To and fro, this. This is to and fro motion. Okay, of an object. This motion is also known as oscillatory motion. Oscillatory motion is also like the pendulum is moving. Like pendulum is here, so it is moving in this way. Okay, so it is vibrating like this. We can say that. But it is at the, like you can see that thing because it is bigger in size. But the atoms and molecules are very small. So when they are doing this to and fro motion like this, like this, like this, so it is not visible to us. But what we can do, we can just sense that, we can just feel that. So that is all vibration. So another name of it is the oscillatory motion also. And what is one oscillation is what? Completing the from the mean position, if the thing is going to the extreme and coming to the next extreme and coming back to the mean position, this is complete one oscillation. So if I say in case of atoms and molecules, what would it be? Like the particle is here and somebody is applying any energy from this side, that means giving a sound like striking or speaking something. So now this will get energized. So this particle will move from here, now coming back and moving to the next extreme point and now coming back to the mean position. So this we can say that one oscillation is complete here. So what is the another name of vibration? It is oscillatory motion. And if we see how does it produce, how does sound produce? So it is due to vibrations only. So students, here are some examples related to the vibrations. Okay, so see, have you done this before? Like you can take the pan of your home and strike it well. Okay, like this. So when you touch that pan again, you will feel that the vibrations are there in that aluminum part. Okay, so this is what the vibrations is. Okay, another example I am having is like this. Even you can pluck the rubber band. Okay, and I guess you have seen the guitar also. So in guitar we are having different strings, and that string could also be get plugged like this. And when you are doing this, so when you touch any of the string at that time, you will feel the vibrations. And I guess this game, you all have played this game once at a time. Okay, what we have done this, we take the rubber band and we just pluck like this, okay, the piece of paper. So but here in the rubber band, what we see, that rubber band not just stop at the moment when we start plucking it, but it goes on vibrating for a while, and then after some time it stops. So that is a vibration, and you all have felt that. And one more example, so you can just now do that practical, that you can just hold your throat like this with your fingers and speak something. And when you are doing this, you will feel that here you will feel that something is going inside your hand. That is vibrations. Okay, so these all are the practical examples of vibrations. Now I guess you all get clear that vibrations is the disturbing of the around atoms and molecules. Okay, now so vibrations producing sound. We know that due to vibrations, sound is get produced. Now it can travel through the solid, liquid and air both, because you know in solid, liquid and air, in three of it we are having atoms and molecules. Okay, no doubt in it. Okay, so these atoms and molecules are get only vibration. But what if the thing is vacuum? Okay, if we are having a vacuum space, so that we can say here we are not having any solid, liquid and air, that is the gas material there. So will the sound get travel in vacuum also? No at all. Okay, so in vacuum we cannot hear anything because there are no atoms and molecules, no particles are there. So who will get disturbed then? Who will get vibrate then? And who will get the information transfer from one end to another end? Because when we are having different particles and atoms, they all get vibrate and vibrate to others also. So that here is the speaker and here is the listener. So the speaker will speak, and this vibration with the help of these particles will move from one point to the other point in this manner. Okay, the vibration of this will be in this manner only. So now the information will get towards the ear of somebody, and that information now can be audible, can be heard by the person. Okay, so we can say now solid, liquid and gas are the mediums which we require to hear the sound. Okay, so here like the example, when the bell rings at school time, so this produces a vibration, and you know from that place, from the place where the bhaiya is striking that hammer on the board, from their place till your class you are having all surrounded with the air particles, right? So these air particles get vibrate like this and reach to your class and then to your ear, and then you are able to hear the noise of bell. Okay, so this is the way how vibrations produces sound. Now we are having law of conservation. You heard about it. We have seen that thing in the chapter work, energy and power. So what does law of conservation is speaking about? It is saying that energy can neither be created, we cannot make it, and we cannot destroy it. So it cannot be destroyed. Cross. Yeah. Energy is all about itself. We cannot make it, we cannot destroy it. So this is what law of conservation of energy, and it also applicable on sound. Likewise, I am just quickly giving you an example. You have seen nowadays we are not having the hammer bells at schools. What we are having? We are having electrical bells. So here, in case of electrical bell, what is going? Electricity get transformed into the sound energy. That is why we are able to hear the sound. Now electrical energy is converted into sound. One more example we are having is like this. See here, one boy is clapping his hand. Okay, so what is going on here? Here, the muscular energy of the boy, that he is using the muscles here. So we can say the mechanical work has been done. So he is using this muscular energy, and that muscular energy is converting into the sound energy. So we can say, yeah, the law of conservation of energy is also applicable in case of sound.